I'll give you 3 minutes.
Hello everyone, I am Udricil, it's difficult to pronounce, Udricil Tomochoke from ETSIS Laboratory in Cergy, France. I'm pleased to present our work on WIP-based insect recognition with light deep network. Okay, so that is the plane of the presentation. To let begin, our work main focus on detailed spaces. Dead spaces are not just a nuisance, but they represent a real high medical and veterinary interest due to the quick propagation and danger they pose against human and animal. So here we have a worldwide distribution map of Aedes albopictus and Aedes aegypti. Aedes albopictus is a vector of many diseases such as dengue fever. She first comes from Asia and then they widespread in many regions in the world. So there is a real need of tools that can be used in the field to identify dead species to prevent many diseases. We think that we have to develop tools that can be easy to use in the field, cheap, transportable, or portable. Here we have an example of the equipment we are using in our project. So for this purpose, currently, the conventional method rely on expert entomologists with a rare and time-consuming resource. Besides, we also have molecular identification, like DNA and protein profiling, which is effective, but the equipment can be really expensive and destructive for insects. Our proposition is to use the ring interference pattern. It's the structural color pattern in the wings, in the transparent wings, who has been used by taxonomists for insect classification. We propose to combine the WIP's image with the convolutional neural network to extract meaningful information for insect classification. So to create the database, we have followed a rigorous workflow from insect trapping in the field to image acquisition. We have moved the background to avoid noise during training, and then expert labeling by our entomologists. Here we have an example of WIPs. WIPs is really different from one species to other and can be really different in the same species with different sex. So our database create is annotated based on the complete taxonomies, the sex of the insect, and other information. We have more data in these papers. Here is an example of the taxonomy of insect in the data sets. We have more than 5,000 images of this of one who represent 147 species. The main challenge with this data set is that it's really imbalanced. For example, for Glossina species, we have more than 5 images, but for species like Chrysops, we just have 10 images. So that represents a really high challenge to train a neural network. Okay, now I will present all the work and the papers we have proposed and the ongoing work. The first paper is about the general identification of detailed species. We have tested several architecture of convolutional neural network. We have focused on lightweight architecture like mobile net, and we found that mobile net-like architecture give a best trade-off between accuracy and speed up. We will make her perfect for mobile use. And based on this, we have proposed a mobile phone application that can be easy to use by entomologists to classify and diptera species. The name of the application is Diptera. For the training of the neural network, we have used only the species we have at least 10 images. It's because of that here we have only 15.8 class. We have also applied some transformation on image to augment the data set to have at 10,000 image during the training phase. Besides this, we have also proposed a more specific paper will take more specific genera who have a high interest in medicine, like Tete fly, who is responsible of trypanosomiasis, Ida species, who is more massive in urban zoo, Anopheles and Culex species. For each of these papers, we attempt a really high success rate for all the species who interest us. The accuracy here attempts 95% for all the species. We have evaluated our neural network on many levels, at the genus level, for the subgenus identification, and for the species identification. The main advantage here is that this approach is really economic and can be usable with a standard microscope. So if you want more data, we have here the reference of on the paper. Now we are trying to extend this work to the Hemiptera and Hymenoptera orders to tackle the agroeconomic impact of this species. For example, here we have pollinator and some pests, and we want to propose to the entomologists or to our partner a tool that can be identified here. And we are updating all the algorithms to take in account this new image. We have also now proposed a new approach based on prototypical network. It's a future learning approach. The main advantage of this approach is that it's adapted when the data set is really scarce and it's easy to add new clays. And in our case, it will be easy to take in account all the image we have, low data, and to add a new species like to add new Hemiptera and Hymenoptera species. For the training, we have used the ResNet 18 neural network, but just a convolutional layer. We have created one prototype by species, and to infer for the classification, we compute the Euclidean distance between the image to classify and all the prototype, and we choose the prototype we have who is more close to the image. Here we have first, after the training, we have analyzed the ability of our model to extract meaningful information. And as you can see on this cluster, we have a clear cluster with consistency with a realistic taxonomy. The first graph is colored by genus and the second is colored by family. The stars here represent all the prototype of each species we have. Besides this, we have also analyzed the hierarchical clustering after training on the test data set. Here, with this graph, you are able to see to which species one species is more close. And it helps our entomologists to know if maybe if you have you discover a new insect, with this graph you can be able to know to which species or to which genus this insect is more close. After that, we have also analyzed the ability to classify classification of our model by genus and by species, and we obtained a really promising result for 47 species. We had just at least 15 images, but now we are trying to test our model to the unseen class, because the advantage, I said that before, the advantage of this approach is that it's easy to add a new class. So with this, we think that with the when we will evaluate our data set on this, we'll be able to say that approach is really nice in our case. So in parallel, we are working on the desktop application, who will be used by our partner. That is the first design of the application. It's really easy to use. We just charge your image and run the prediction, and you are able to select the model you want to use for prediction. It's also you are also able to view where your insect is placed in dendrogram. Okay, so to conclude, our main goal was to propose an automatic identification tool for our partner entomologists, and we attend a really successful survey in classification over 58 cases with at least 95% with our model. We have developed a lightweight model which was used to develop a mobile phone application. And now we are trying to study a prototypical network approach which can be better adapted in our case, and we have attained a really promising result. Now our current focus is in open set recognition, so make our model able to identify unseen species. That is really important for our partner. And now we are trying to deploy the desktop application near to the field to validate our results. And our entomologists are extending the database to include new orders and take her in account. So thank you for your attention. And that is the main member of our teams. If you have any question.
Thank you very much. Interesting questions, yeah.
Sorry if I missed this. This location of the images for the training.
The image
Distribution of the geographical locations from which the insects are training.
I don't have a distribution of the training set, but the training set have just 5,000, 14,000 image. We use 18% of our data set for training and the rest for test. Are
they just European images or?
No, it's for different places. For different places in the world. We have the description in the file. I don't transfer in this. Yes. We have some places from European, Africa, Asia. It's come from different places in the world.
Maybe speaking.
Sorry. It's here.
Gordon?
Yeah, he's showing some selection of wing images with very beautiful, very spectacular coloration.
Yes.
Were they all taken in natural sunlight or were they under special lighting conditions? Because that could take if they were taken under special lighting conditions, they might not be typically what you find in the field.
Can you?
Yeah. So the images with the beautiful coloration wings, were they all natural sunlight images or were they taken under artificial spectacles?
Artificial light with microscope.
Okay, yeah. And so would that be the situation you'd be using for analysing images from the field? You would use them on artificial light and microscope?
Yes, in the field, just separate or just take the views of insect, and then we microscope, we follow the artificial light, and we take the image.
Okay, so you'd use these with physical samples, not from camera tracking?
No.
Okay, thank you.
Yeah, I guess that was my question as well. How can you record more images? I saw the lab bench with the system set up. Do you need that special equipment to be able to record these with images?
No, just the standard microscope. In the field, we trap the insect with I don't know the name in English, sorry. We use a standard method for trapping the insect, and then we just take them with the image with microscope. Not we don't need another equipment or.
Okay.
Okay.
Great, thanks. Okay, I think that concludes the session. Thank you very much, and thanks to all the speakers. So before you leave, we've got a little bit of information.
Yeah.
Yeah.
So we will make a group for the photo report on in front of the building. Also, please, I need exact numbers for the path for tonight and for the dinner and excursion, because remember, we have limited places. I mean, we cannot go to excursion if we have less than 43. So please, if you extend your interest for excursions, inform, don't put the invitation